went to French there, huh? All right. So, number 11 says refer to the home builder's advertisement. The home builder's advertisement, right here. Okay? And it says that the family rooms in both models are rectangular. How much carpeting is needed to carpet the family room in the Western model? In the Western model, the new Western model, we doubled the dimensions. We doubled the dimensions. All right. Well, what's the dimensions here? It doesn't give us, right? It doesn't tell us. It tells us the square footage. The square footage of this room right here is 120. 120 square feet. Okay? Well, can you come up with a way that we can multiply a couple of dimensions to get 120 square feet? Give me an easy one. 60 times 2. Yeah, that's a thin room. 2 feet. Cool. All right. No, but that's okay. It'll still work, right? 60 times 2. That's beautiful. I would have never thought of it, but that's all right. Because it still works. It's 120, right? Now, what if we double that amount? Which we might need to do. And just, because 2 feet, I'd be like, shoot, I could lay down in it. It'd be all right. And then I got 60 more feet of laying down. I can do somersaults all day long. It'd be dizzy. So maybe go 4 and 120, right? Because that would be doubling each dimension. What would my square footage be? 4 times 120. Right? That's how I get to the 120, right? So now I go 4 times 120, and what is it? 480. 480. Oh, that's more than doubled. How come the area more than doubled? Am I recording? Good. Okay. Why? Why the area more than double?
Because you were already doubling it? Or, I don't know, because it was squared?
Because it was squared. Exactly. Because when you talk about square footage, when you double something, and you're talking about squaring it, then what you're doing is you're taking the double and you're squaring it. And that gives you how much? What's 2 to the second power? Come on, guys.
4.
4. Alright, so is this 4 times this? Well, yeah, because we just proved that. That was 4 times 120. So we made it 4 times as big. Right? 2 squared by doubling the dimensions. Does that work every single time? Will that work if it's a 10-foot by 12-foot room? So 10 foot by 12 foot, that's still 120, right? So if I double that, that'll be 20 by 24, right? What's 20 by 24? Times it. 20 times 24. What's 20 times 20? Nope. 24 times 20. 2 times 24 is 480, right? Right? So, every single time you double the dimensions, you quadruple this flooring. Okay? So, does that make sense? So what's happening here is we're going to be quadrupling the flooring. You have 4 times as much. You're going to have 480 square feet of flooring. Okay? Now, okay, that's cool. Yeah. All right, now let's say we have an ice cream cone. because it tells us it's a cone. And it's a big ice cream cone because it's got a volume of 98 pi cubic centimeters. Okay? So it's like this cone, right? And it has 98 pi cubic centimeters. Now, let's take what we know about area, square area, and we'll put it to volume. Now, volume is cubic, right? So do you think the same thing's going to happen to a cubic? Remember, when we take a box, right, and we turn it into a cube, right, we just take the area of the bottom and multiply it by the height to find the volume, right? It's the same thing with this. Taking the area of the bottom and multiplying it by the height. Okay? So, if another cone, right? If this cone is 6,272 pi, right? And this cone is 98 pi, right? Then how are we going to figure out how many times bigger is this cone than that cone? Well, we figure out how many of these go into that. So we take out a calculator, beep, boop, 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 beep, and we divide this by this, right? And what do we get? Right, Eddie? What do we get? Very good, Eddie.
You're welcome.
64.
Yes.
Okay? But it's not 64 times as big, right?
Yeah.
And this is a very important part. You should take a look over here on this board. It's not 64 times as big. The number we get to is 64. But remember, some number cubed is equal to that. However many times bigger it is cubed to get to that. So in order to figure out the equation, or figure out x, I have to do the opposite of cubing. Does anyone know the opposite of cubing? Guys, pay attention. This is on the state test. Square rooting, but I'm not going to square root. I'm going to cube root. Right? A square root will get rid of a square.
Yeah.
And a cube root will get rid of a cube. When I do to one side, I got to do the other. Then you're like, how do I do this? How do I do this? And I'm going to show you if you pay attention. Guys, focus. Everyone in here can do this. 64, break it down. Use the first prime. Our primes are 2, 3, 5, 7, 11, blah, blah, blah. Okay? The first prime is 2. Does 2 go into 64?
Yeah.
How many times?
Too many.
2 goes into 6. 2 goes into 4. Right?
Okay.
How many times does 2 go into 32? 2 goes into 3 once with 1 left over. 2 goes into 12. 6 times.
It's tricky.
Short division. 2 goes into 16.
8 times.
Okay, now we got it. 2 goes into 8.
4 times.
2 goes into 4.
Twice.
2 goes into 2.
Once, right?
Alright. Watch this. I made this method up. This is a really easy method to learn, Dom. If your eyes are open and you're taking notes. See this 3? That's how many we're trading. I'm going to circle 3 of these 2's. And then I'm going to circle another 3 if I can. Can I circle another 3? and I'm going to trade 3 of these 2s that are inside here for 1 outside. I'm going to trade 3 of these 2s that are in there for 1 outside. And what I'm left with is what? 4. Okay? This cone is 4 times as big as this cone. That's the ratio. 4 times as big. Now the volume, the dimensions are 4 times as big, right? The volume is a lot bigger, right? The volume, right, is cubed. 60 times bigger. 64 to be exact. But the dimensions are 4. Okay? Next. Still on? Barely making it?
Barely.
Alright, 15. Again, it's easy. Does this cone look like this cone?
Well, it does, but like
They're
it's bigger.
similar. It says they're similar. So it's this, and equals. What that means is 10 over 14 is equal to 2 over x. And then what do we do to solve?
Times 14 times 2 and 10 times x.
That's it. 14 times 2,
What's on 6?
which is
What's on
2 times 14, right? Equals x times 10, which is 10x. How do I solve? Well, first I got to do 2 times 14, which is 10x equals 28, right?
Yep.
And then I divide by
10.
10. And how many already got x is equal to 2.8? How many got that? How did I do that?
Divide 10.
Not just divide.
No.
I moved the decimal over 1. Okay? Because I was dividing by 10. But another way you can do this is 28 over 10. And then do your upside down division. What goes into 28 and 10? 2, right? How many times? 14 and 5. How many times is 5 going to 14? 2. With how many left over? 4. Left over the 5. Is 4/5 the same as 0.8? Yeah, because 4/5, think of it, that's 8/10. Oh, 0.8, 8/10. Okay, 4/5. All right, so that's the next to last problem. We got the last problem. Okay, now I think I ran out on the last time, so hopefully I'll have enough juice. I've got. All right, I'm gonna just do this up here. Focus up here real quick. Okay, we got RST. Right? And it's 3 and 3 and X. Okay? And they said that RST is similar to QSB. So we got QSB. Right?
How about KT?
Alright? And they said that this is 3, and this is 3, and this is 8. Is that correct? Okay? Now, QSB. What that means is this. RST, or in other words, 3 and X, right, is similar to QS, right? Well, how much is Q to S? 3 and 3, which is, come on,
Six.
there you go, 6. And then Q and V, which is,
8.
okay? And we just do our trick here. Boom, boom, equals. So we got 3 over x, or I can do it right here. 3 over x is equal to 6 over 8. Now watch, I'm going to do this even easier. What times 3 is 6?
2.
2.
Right? So 2 times what is 8?
2 times 4.
So x is 4. So again, I could go 3 over x equals 6 over 8. And I could be doing cross multiplication. So 3 times 8 equals 6x. So 24 equals 6x. So then divide by 6, I get 4 equals x. Okay, either way, x is 4. Oh, and I made it.